In this lesson, 10.3, we are going to find out how to find the area of regular polygons. So in our past units, we've looked at how to find the area of triangles, rectangles, parallelograms, trapezoids, rhombuses, and kites. In this section, we're going to look at how to find the area of a special group of shapes, all regular polygons. So those two words are very important. Recall, polygon is essentially any two-dimensional shape. Polygon could be a triangle, quadrilateral, pentagon, hexagon, octagon, decagon, any one of those. When we call a polygon regular, regular means that all of the sides of my polygon are congruent and all the angles of my polygon are congruent. All the sides are congruent and all the angles are congruent. In order to find the area of a regular polygon, we're going to have to talk about two important measurements in a regular polygon. Two important measurements. In order to describe one of these, imagine that I circumscribe a circle around my regular polygon. Right, so here's my regular. This has 6 sides, so hexagon. Imagine that I put a circle perfectly around that hexagon, where all the vertices are on my circle. We would refer to the radius of my polygon, so the radius of this hexagon, as the distance from the center. So notice if I put a circle around my hexagon, the center of that circle we would also refer to as the center of my polygon. The radius is the distance from the center to a vertex. From the center to a vertex. Vertex is like the corners of my polygon. Vertex, 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 vertex. That's a radius. There's a radius, there's a radius, etc. That's one significant measurement we'll need to know. The next is called an apothem. An apothem, as labeled here, is, we'll say, the perpendicular distance. So it has to be perpendicular from the center again, the center of my polygon, to a side of my polygon. So perpendicular distance from the center to a side. That just means start at the center, go to one of your sides perpendicularly. Right? This distance is perpendicular to my side. We would call that an apothem. Here would be another apothem. Here would be another apothem. Distance from the center to a side. It's perpendicular. That's the second important measurement. So you have it nicely labeled the center, there's a radius, there's an apothem of this regular hexagon. Those are going to be key measurements when talking about the area of a regular polygon. Something else we will need to know are certain angle measurements if I have a regular polygon. So we're going to practice with this figure finding some angle measurements. This has 1, 2, 3, 4, 5 sides, so it's a pentagon. It's a regular pentagon, which tells me all the sides are congruent, all these angles are congruent. That's all it means to be regular. And I want to find the measure of the angles. So here's angle 1 in here. But notice, if I put the center in my regular polygon and we draw radii to each of the vertices, it's going to create 5 congruent angles in the center here. All 5 of these are going to be congruent. And if you notice, if I add up all those angles, these angles make a full circle. How many degrees in a circle again? 360 divided by, this was a pentagon, it has 5 sides. That created 5 angles in the center of my figure. So just take 360 degrees and divide it evenly by 5, and you get 72 degrees for the measure of each of those angles. So angle 1 is 72 degrees. Just take 360 and divide it by the number of sides in your polygon. Notice angle 2 in this figure is just this part. If I focus in on this angle, we said was 72 degrees. We drew an apothem from the center to the side. When we draw that, what it does is it bisects this angle, cuts this angle directly in half. So what we got, the 72 degrees for angle 1, if I draw an apothem, it just cuts that 72 degrees in half. So the measure of angle 2 is half of that 72 degrees, which makes the measure of angle 2 36 degrees. To find the measure of angle 3 down here, now we just need to use our right triangle. Right? If I use this triangle right here, I have a 90-degree angle, 36-degree angle. What's the measure of angle 3? Angles in a triangle add up to 180 degrees, so just subtract 90, subtract 36. We've done this many times in class now, and that would leave you with 54 degrees. 54 degrees. Measure of those 3 angles. Those angles will come into play, and we'll see that in the examples we're going to work on in this section. Okay, so at this point we've talked about regular polygons. I've introduced 2 new measurements in a regular polygon, the radius and the apothem. We found some angle measurements in our regular polygon, but we haven't found the area of any figure yet. Well, that's what we've gotten to now. So the one nice thing about the area of any regular polygon is we're just going to have one formula for the area of all polygons. So regular pentagon, regular hexagon, regular octagon, they all have the exact same formula. And the area of a regular polygon is 1/2 the perimeter times the apothem. P stands for the perimeter of my polygon, A for the apothem. A very short side note, I skipped over this postulate. Postulate 10.1 just says, if 2 figures are congruent, then their areas are equal. If 2 figures are congruent, if they're the same, then their areas are equal. Areas are the same. This formula for the area of a regular polygon, if you're interested where in the world we get it from, essentially what I'm doing, I break my regular polygon, I'll use this picture as an example, into triangles. We draw the center and we draw radii to all our vertices. It creates 5 congruent triangles in this case because I have 5 sides. Well, the area of a triangle is 1/2 the base times the height. In this case, the base is one side of my figure. The height is the apothem. So where we get this formula from is essentially thinking I find the area of one of these triangles and I multiply it by however the number of sides are. Right? If it's a pentagon, I have 5 triangles. If it were a hexagon, like up here, I'd have 6 triangles, however many sides I have. If you add up the bases, that's just the perimeter of my figure. So that's where we get the perimeter, and the height of those triangles is the apothem. So that's where we get the apothem. Whether you know that or not, doesn't matter. You just need to be able to use the formula. It's nice and short. 1/2 perimeter times apothem. This formula is also on your formulas sheet that you get for the test. Down here in this section of area, we've already shown you the area of rectangle, parallelogram, trapezoid, rhombus, and kite, triangle. Right here, area of a regular polygon is 1/2. P stands for perimeter, A for the apothem. So you have the formulas. What you just need to know is what all these letters stand for. Okay, with that formula, let's move to some examples. Some of these will go quick, some of them require a little bit of finding the measurements we need. We'll start here with this decagon. What's the area of a regular decagon? Decagon has 10 sides. And the area is going to be 1/2 the perimeter times the apothem. So I need to know the perimeter and I need to know the apothem. Well, I'm told that one side is 8 inches and a decagon has 10 sides, so the perimeter would be 8 plus 8 plus 8 plus 8 plus 8 plus 8 10 times, or just 8 times 10. The perimeter, one side is 8, I have 10 sides, so 8 times 10, that's my perimeter. And the apothem, also given to me. Apothem is the segment from the center perpendicular to a side. 12.3. That's all I need. If we just multiply this, you should get 492. We were dealing in inches, so the area is inches squared. 492 inches squared. Flip to the top of the next page, and we'll work on this next example. What is the area of a regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides? So I gave you a picture of what's close to a regular pentagon over here. Once again, the area is going to be 1/2 perimeter times apothem. Let's use the measurements we're given. So here's where I'm going to have to draw in some of these pieces. Put the center of your pentagon somewhere in there. It says we have an 8 centimeter apothem, so I can draw that. Apothem is perpendicular to the side. That's 8 centimeters. And a side of 11.6 centimeters. So the perimeter, I know one side is 11.6. I have 5 sides. So the perimeter would be 11.6 is one side times, I have 5 sides, 11.6 times 5. And I'm given the apothem again. The apothem is just 8. So we just need to multiply all those together. If you do that, you should get 232. We were dealing in centimeters, so centimeters squared. Heading down to our next example, a honeycomb is made up of regular hexagonal cells. Hexagon, 6 sides. The length of a side of a cell is 3 millimeters. So we can go ahead and label one of these sides 3. What is the area of the cell? Round to the nearest unit. All I'm given is the measure of one side of a regular hexagon, and I'm expected to come up with the area. For the area, I need to know what 1/2 the perimeter times the apothem is. I could find the perimeter. I know one side is 3. I have 6 sides, so the perimeter is just 3 times 6. How to find the apothem, though? My apothem is this distance, perpendicular to my side. To go about finding this, let's draw in some helpful radii. If I draw radii into my figure, and we break this up into a bunch of congruent triangles. One thing the apothem does, an altitude in this, because it's an isosceles triangle, is it bisects this side. So if the side is 3 millimeters long, each of these pieces is half of 3, or 1.5 millimeters. That's what an altitude does, bisects this side, because the triangle's isosceles. And I need to know what one of these angles is in my triangle. I have a right triangle. This is where finding the angles came into play from earlier. So if I add up all of these angles, it makes a full circle, 360 degrees. I have 6 sides, so I have 6 angles formed in the middle here. 360, if I divide that evenly by 6, gives me 60 degrees. So any one of these angles here is 60 degrees. Well, when I draw the apothem, that bisects my 60 degree angle, cuts it right in half. So this angle in here is 30 degrees, which makes me a special right triangle, my 30, 60, 90 triangle. And what I'm trying to find is the apothem, this side right here. So let me redraw this over here. My 30, 60, 90 triangle. 30 up there, 60 here. The side I know is 1.5 down here. And I want to find this side. This side is my apothem. Well, write the ratios of our sides around. Across from the 30 degree angle is x. Across from the 60 degree angle is x times the square root of 3. And across from the right angle, my hypotenuse is 2x. This is nice and easy to me again. I'm told the side that is x is 1.5. So to find this side, just plug in 1.5 for x. My apothem is 1.5 times the square root of 3. We found our apothem. Come back and put that into our area formula now. And to find the area, all we need to do is multiply all of these together. Notice the directions